Okay, now we do question 3. Question 3, evaluate the integral double integration from negative root pi to root pi and minus pi minus y squared pi minus y squared. This is negative, this is positive, and it's sine x squared plus y squared, and it's dx dy. Now, using polar coordinates, again, it's usually helpful to sketch. So, since dx is done first, so the x limits are between this and this. And the y limits are between root pi and minus root pi. Now, if you have a calculator, root pi, you don't need to know this, but it's like roughly 1.7, about 1.7. Okay, now how does the graph look like? If I go into my x and y, in order to sketch something that's not a straight line, we prefer putting 3 points. So for this one, I'll say, I'll put negative root pi and positive root pi, because that's the start and the finish. So minus 1.7 and positive 1.7. And I'm also gonna put 0, because it's between the two numbers. If I put negative root pi, square it becomes pi, and pi minus pi is 0, so this point gives me a 0. 0 gives me root pi, and root pi here gives me 0. If again, you don't have to show this if you know how to sketch it. I always find this helpful. If we do the same for this, again, we can put negative root pi, 0, and positive root pi. This will give me 0 again, this will give me 0 again, and this will give me negative root pi. So we say root pi is about 1.6. So if we say this is 1, this is 2, this is 1, this is 2, so just be as accurate as possible. This is 1, this is 2, this is 1. If I know that root pi is roughly here, if it's positive, because it's less than 2 by a little bit, so it would be less than 2 everywhere. So let's start with the first one. At 0, you always sketch x first. At 0, you're minus root pi, so you have this point here. At root pi, you're 0. And at 0 again, you're root pi. So it'd be this part where this is root pi, this is root pi, this is root pi. If I sketch this portion of the curve, at negative root pi, at 0, you're negative root pi. At negative root pi, you're 0. So eventually you'll see that this would look like a complete circle. And the radius of this circle would be root pi. So now, how can we switch this from the xy plane to the polar system? You know, in the polar system, x equals r cosine theta, y equals r sine theta, and x squared plus y squared equals r squared. You also need to know this, that dx times dy is r dr d theta. So this integral, watch, sine, instead of x squared plus y squared, I can say it's sine r squared. Instead of dx dy, r dr d theta. So now r is first, and since r is first, let's see what the radius is. The radius is from 0 to root pi. So the radius is from 0 to root pi. That's my radius. Some people like to do it this way. They like to do this portion of the circle times 4. And I prefer doing it this way because it's easy to see that the radius is from 0 to root pi, and the angle from 0 to pi over 2. So 0 to pi over 2, but this is only a quarter of a circle, so I'm going to multiply this by 4. Going to erase some of this. So this is what we're integrating. This is done u substitution. So to integrate this, u is r squared, then du is 2r dr. Divide by 2. So that means that for the first one, you're integrating sine u, r dr is du over 2. This is only the first part of the integral, the sine. Integral of sine is minus cosine, so you're minus half cosine u. You don't put the limits here, you put it after you integrate because this is u. So it's negative half cosine of r squared, and it's 0, negative root pi. We plug root pi, so it's half cosine. Root pi squared becomes 5. And 0 becomes 0. Cosine of pi is negative 1 times negative half, that's half. Cosine of 0 is 1 times minus half, that's minus half, and a minus plus half. So the answer is 1. If the answer is 1. So now I know that this answer of this integral is 1. So I can say, now I need to integrate the 1 d theta. The integral of 1 is theta 0 pi over 2. So it's pi over 2 minus 0 times 4. That's 4 pi over 2. That's 2 pi. So the answer for this is 2 pi. So that was question number 3. Question 4. Let me have a look at it. Yeah, I haven't seen anything like this, so I'm not. It's kind of strange the way he has it. I'll tell you what I think he means. It's from 0 to pi over 4. And it's from 0 to 2 cosine theta. And he had this weird thing of r cos theta, r sine theta, r dr d theta. He wants you to do this double integral. He wants you to sketch first. Okay, we're going to sketch this. I'm gonna add, because you're sketching from theta 0 to theta pi over 4, which is 45 degrees. So I'm gonna add the line for 45 degrees, or pi over 4. And I'm also, and this is of course angle 0. I'm also gonna do one thing. I'm also gonna do this. Maybe I should show this with a different color. I'll do angle 30, because that's another famous angle. 30 degrees, or pi over 6. I'm also gonna divide this into 1, 2. This is the same. 1, 2. And this is the same. 1, 2. That will tell you basically how the graph is supposed to look like. Now, this means that since we're doing the dr first, that the radius of this is limited between 0 and 2 cosine theta, where theta is limited between pi over 4 and 0. So I want to sketch this. I'll do my table for theta and r. I have from 0 to 45, so I'll do 0. I'll do angle 30, which is pi over 6. and I'll do angle pi over 4. You plug 0, cosine of 0 is 1, so that becomes 2. Pi over 6, which is 30 degrees, cosine of this is root 3 over 2. So 2 times root 3 over 2, so that's root 3. And root 3 is about 1.7. If we put pi over 4, 45 degrees, cosine of 45 degrees is root 2 over 2, or 1 over root 2, but the answer is root 2. And root 2 is about 1.4. So now what? At angle 0, this is angle 0, radius is 2. At angle 30, you're 1.7, so you're about here. So it goes like this. And at angle 45, you're 1.4, so you're like here. So it will look like something like this. So this would be your region. Good, so this is your region. You can show it this way. This is what they want to, I think that's all they want you to do in part A. And now in part B, what if this is only y? How would you integrate this? I have to stop this video now. It's because it will make it hard for me to upload it. Next part we'll do the integration.